This video is a continuation of the content from section 7.2. I want to start talking about the slope-intercept form of the equation of a line. To begin with, we've been talking about linear equations with the general form of ax plus by equals 2c. What I want to talk about is if we were to change this by subtracting the ax. So if I could subtract ax from both sides and solve for y, divide by b, solve for y, it would be of the form a equals 2mx plus b. So this is our general form of the linear equation, where a, b, and c are all real numbers, and a and b are not both 0. And this form is what we call the slope-intercept form. And the coefficient and the constant, the m and the b, are going to represent something a little bit different when it's in this form. So let's first talk about a line that's in slope-intercept form. So let's take this: y is equal to 2/3 x plus 5. Okay, so the first thing I'm going to do is, actually let's make that a 6, and you'll see why in a minute. Plus 6. So the first thing I want to do is I want to graph this equation. So you can see it does have an x and a y term. The coefficient of y is 1. The coefficient of x is 2/3. We could convert this back to ax plus by equals to c and have it in general form to prove that it is indeed a linear equation. But hopefully you'll see that the exponents of x and y are both 1. So this is a linear equation. So let's start off by reviewing. I'm going to graph this by first finding the x-intercepts. And if you recall, the x-intercept, so that's the point where the graph crosses the x-axis, is the point where y is 0. So I'm going to substitute 0 in for y equals to 2/3 x plus 6. Subtract 6 from both sides because I want to solve for x, and I get 2/3 x is -6. To remove this 2/3, I need to divide by 2/3, which is the same thing as multiplying by the reciprocal. And the multiplicative property says whatever you do to one side, you must do to the other. So this cancels out, and I end up with x is equal to 3 times -6 is a -18. -18 divided by 2 is a -9. So my x-intercept is going to be the point -9, 0. And then my y-intercept, remember we find our y-intercept, so that was my x-intercept. To find my y-intercept, I need to set x equals to 0. So I'm going to come back to that same equation, y equals to 2/3 times 0 plus 6. 2/3 times 0 is 0, and my y-intercept is simply 6. So that gives me the ordered pair where x is 0, y is 6. When I plot these on the number line, my x-intercept is -9, 0, so I can come over here. That's my x-intercept. My y-intercept is 0 and 0, 6. And now I can draw my line. So my line goes through, and sorry about that. It's a little bit wonky here. Trying to draw this on my tablet here. So here is the graph of this line. You could, if you want to check a couple more points, you could pick some x values, substitute them in to find their corresponding y values, and hopefully all those points would also be on this line. If they weren't, then we made an error somewhere. Now what I would like for you to see is that not only did we find the intercepts for graphing, we can also find the slope. We could either use these 2 points to find the slope using the slope formula. M is y2 minus y1 over x2 minus x1, substituting in our x-intercept and our y-intercept. Or we can simply look at the graph. So to go from this leftmost point, I would go up 1, 2, 3, 4, 5, 6, and right 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, giving me a slope of 6 over 9, which can be reduced to 2 over 3. Now, I would like for you to go back to the original equation and notice a few things. If you look in this original equation, these numbers look like things we found before. This coefficient of x happens to be my slope. And the constant term of 6 happens to be my y-intercept. So really what I was doing here was I was simply showing you that if it is in this form, which we call the slope-intercept form, we can find the slope and the y-intercept by simply looking at our equation. And I've just proven that to you here by finding the y-intercept and the slope of that line. You do not need to know or to replicate this. I just have a hard time just giving you the equation and saying this is how it is. But now I'm going to go back and I'm going to clear all the ink here, and I'm going to say this is how it is. If your linear equation is of the form y equals to mx plus b, then the m is always your slope, and the constant, so the m, which is your coefficient of your x, is always your slope, and your constant term is always your y-intercept. And once we know that, it's pretty straightforward. We can graph this line. So if you're given an equation of the forms, let's say y equals to negative 3x plus 5. If it's given to you in this form, you've got all the information you need to know to graph it. You know that your slope is negative 3, and you know your y-intercept is 5. Remember, if your y-intercept is 5, the point 0.05 is your y-intercept. Now, to graph this using this information, we first plot the point that we're given. So the point that we're given is our y-intercept. So I can go to 0.5 and plot that point. It is indeed on the y-axis. And then I'm going to use my slope to find the next point. Because remember, your slope defines your vertical and horizontal change from one point on the line to another. Now I'm going to write this as a ratio. We can write negative 3 as negative 3 over 1 because this tells me my vertical change and this tells me my horizontal change. So I'm going to go back to the point that we plotted, our y-intercept. So this was 0.5. And from there, I'm going to use the slope as if it's given me direction. So I'm going to go from there, I'm going to go down 3, 1, 2, 3, and I'm going to go right 1. And that's where I'm going to put my second point. And here I can draw my line. My y-intercept is 0.5, which is this value right here. And my slope from that point to the next point, I had to go down 3 and right 1. Now, you can always graph any equation by picking x values, negative 2, 0, and 2, substituting these values into your equation, find the y value, and therefore come up with your line by plotting 3 points. But if it's in the slope-intercept form, it's also very straightforward because you're given the information that you need. Okay, let's look at another problem. So let's say that your problem was 2x minus 4y equals to 12. Okay, so here you could, if you're asked to graph this, you could make your table. You could pick 3 values for x, substitute them in, and find y. But this problem is actually asking you to graph using the slope and the y-intercept. So the first thing I want to do is put this in slope-intercept form, which simply means solving for y. So I want to remove everything from the y. So first I'm going to remove this 2x by subtracting 2x, performing the opposite operation. This gives me 2x minus 4y equals negative 2x plus 12. And remember that your slope-intercept form is y equals to mx plus b. So we try to put our, just to remain consistent, we put our our variable term first. 2x minus 2x is 0, so this is going to give me a negative 4y equals negative 2x plus 12. These are not like terms, so I cannot combine them. And the last thing I'm going to do is divide everything by negative 4, because our goal is to isolate our variable. And when I do that, I get y is a negative 2 divided by a negative 4 is going to give me a positive 1/2 x. We don't usually see the 1 there, but you can write it as 1/2 x minus 3, because 12 minus 4, excuse me, 12 divided by a negative 4 is a negative 3. All right, so back over here, our slope-intercept form is y equals to mx plus b. Once it's in this form, we know what its slope is. So the slope is going to be 1/2 because it's your coefficient of x, or of your variable term, and your y-intercept is negative 3, which we know your y-intercept is when x is 0 and y is negative 3. So the first thing I'm going to do is plot my point 0, negative 3. So I'm going to plot that point first. And from there, I'm going to use my slope, which is a positive 1/2. The 1 is my vertical change, so that tells me I need to go up 1 unit. And the 2 is my horizontal change, so that tells me I'm going to go right 2 units. And I'm going to plot that point. And once you have those 2 points, you can draw your line. Notice when I go back to use my slope, I don't go back to the origin. I find students have a tendency to want to go back to the origin. You don't go back to the origin, you start from the point that you plotted, because the slope gives you directions from one point to the next. Okay, let's look at an application with linear functions and their graphs. In this problem, as we age, daily stress and worry decrease and happiness increases, according to an analysis of 340,847 U.S. adults ages 18 to 85. The graph shows a portion of this research. So the graph shows 2 data points. So the graph shows that at age 22, your percentage of Americans reporting a lot of stress is 49%. And you can see they put that same information into a line graph over here by creating an ordered pair where your x value, or your input value in your function, goes on the x-axis, and this is your age, and your y value, your output value, goes on the y-axis, giving us the ordered pair 22 and 49. So at the age of 22, 49% of Americans reported a lot of stress. Now, by the time you're 62, hopefully it goes down, and so this is saying that at the age of 62, so we found 62 here on our line graph and plotted 29%, and that's how we get this ordered pair. So the question says to find the slope of the line passing through the 2 points shown by the voice balloons. Express the slope as a decimal. So to find the slope, since we're given 2 points, it might be a little bit complicated to try to do this visually and count the vertical change and the horizontal change. So our vertical change is going to be y2 minus y1. Our horizontal change is x2 minus x1. And that gives us y2, and it doesn't matter, as we mentioned previously, which one of these you call your point 1 and which one you call your point 2, as long as x1 and y1 come from the same point and x2 and y2 come from the same point. So we're going to take y2, which is 29, and subtract y1, which is 49, over x2, which is 62, minus x1, which is 22. And when we do that, we end up with 29 minus 49 is going to give me a negative. I don't have my calculator right in front of me. There we go. So 29 minus 49 will give me a negative 20. Or excuse me, yes. Will give me a negative 20. And 62 minus 22 is going to give me a 40. And when we divide this out, this is going to be 20 divided by 40 is going to be 1/2, or 0.5. So that's going to give me a negative 0.5. All right, so we found the slope. So the slope is negative 0.5. It's asking us to express it as a decimal. And use your answer from part A to complete this following statement. Okay, so this is important. This is when you talk about what these numbers mean. For each year of aging. So what we really did was we found the rate, we used our slope as the rate of change. We actually found the rate of change. as our age decreases, what's happening to the percentage. And it's as if we're averaging it out over those 40 years. So we're finding out the change in the percentage of Americans reporting a lot of stress divided by the number of years. So we can actually just figure out what it's happening each year. And so for each year of aging, the percentage of Americans reporting a lot of stress decreases by negative 0, or excuse me, we don't need to use the negative because we're already using the word decrease. So we can, again, we can generalize this by saying that each year the percentage of Americans reporting a lot of stress decreases by 0.5 or 0.5%. The rate of change is 0.5% per year. So rate of change is another word for your slope. Your percentage is decreasing, so we could say the rate of change is negative 0.5% per year. So the percentage of Americans reporting a lot of stress decreases by 0.5%, or a rate of change of negative 0.5% per year. Okay, in this next application problem, it's talking about grade inflation in U.S. high schools. In recent decades, high school teachers have given higher and higher grades to students. This bar graph shows the percentage of grades of A and C for high school students entering college. So you can see the dark orange is 1968. So in 1968, the number of students entering college with A's was 18%. And then in 2008, the number of students entering college with A's was 47%. In 1968, the number of students entering college with C's, with grades of C, was 23%, but then in 2008, it was down to 5%. So when we think of your average rate of change, remember this is simply our slope. And what you're doing when you're finding your average rate of change is you're finding out how much your output, how much your values, and in this case your percentages, are changing over the course of that many years. In this case, there's 40 years. So we want to find a linear function in slope-intercept form that models this given description. Each function should model the percentage of the particular high school grade, P of X, of students entering college X years after 1968. So here in 1968, X is going to be 0, and in 2008, X is going to be 40 because it's 40 years after 1968. So we can look at these points as ordered pairs, this first being 0 for 1968, the percentage was 18, and then in 2008, it was 40 years later, so X is 40, and your output was 47%. So if we want to find the rate of change for that, really we're simply finding the slope, which is going to give you your y2 minus y1 over your x2 minus x1. So what I just want to do is find the rate of change of A's, the percentage of A's that we're given. So I'll call this x1 and this y1, this x2 and this y2. And to find my rate of change, I subtract my y's. So I'm going to have 47 minus 18. So this is the difference in the percentages divided by the difference of the years. So 40 minus 0. And when I do that, 47 minus 18 is 29 divided by 40 gives me a 0.75725. So this is telling me each year, because I'm dividing it by the number of years, each year the percentage of A's that were given increased by 0.725%. So let me write that here. Each year the percentage of A's given increased by 0.725%. And this is on average. We don't know that each year that it increased exactly this much, but when you average it out over this is the change in the percentage over the number of years, it averages out to be about 0.725% each year. The initial amount in year 0, the initial amount, the percentage was 18, so 0.18. And so our initial amount is going to be our y-intercept. So if we were to write this as a linear equation in slope-intercept form, y equals to mx plus b, our rate of change is 0.725 per year, where x is the number of years after 1968, plus 18. And if you think about it, if you were to substitute 0 in for x, because that's the number of years after 1968, it's going to be 18. 0 times 0.725 is indeed 18. So this is your equation in slope-intercept form. This is your rate of your change or your slope, and this is your initial amount. So your rate of change or your slope, and then this is your initial amount. Now, the actual problem, you'll notice, actually gives you this amount. You don't have to find the slope, but I wanted you to see it worked out here. So the problem says in 1968, 18% of the grades for students entering college were A. This has increased at an average rate of change. So when you see average rate of change, that's really your slope of 0.725% each per year since. So we can just, we didn't even need to do this. We can actually just take that information and say our rate of change is 0.725 per year, which is x, added on to our initial percentage, which our initial percentage was 18, or our y-intercept. With that in mind, we can do this second problem, because again, they give you this slope. In 1968, 23% of the grades. So in 1968, our initial amount was 23% of the grades were SC. This has decreased at an average rate of change of 0.45% per year. So it's decreased, so our slope is going to be a negative 0.45x plus 23 each year. And let me rewrite that up here. Actually, let me just erase this and let's look at this problem right here. So in 1963, where x is 0, the output was 23. So this is our y-intercept, or as we're looking at this problem, it's our initial amount. And it has decreased, so our slope is going to be a negative at an average rate of 0.45. So when we write that in our slope-intercept form, it's going to be negative 0.45x plus our initial amount, which is 23. And, you know, the same way that I found this 0.725 in the previous problem, you could find it here, where your first ordered pair would be 1968. The percentage was 23, and then 40 years later, the percentage was 5%. And you could set this up, slope-intercept form, 5 minus 23 over 40 minus 0. And the change, if we subtract 23, averaged out over those 40 years, ends up being a negative 0.45. And that's where they got this value. All right, you'll be doing a couple of problems like this, and in my math lab you'll be working just basic problems with slope, and you're finding your x and y intercepts as well as using your slope-intercept form. So please let me know if you have any questions.